So this is a next video, and this is a series of lectures, and in this lectures what I will say about in this lecture I will say about the definition or the mathematical definition of Laplace transform, and I'll show how to solve Laplace transform of how to evaluate Laplace transform of some common functions. So suppose there is a function which is given by f of t. This is a function of t, and t is greater than or equal to 0, and if you're saying that, then the Laplace transform of f of t can be given as, this is a simple of Laplace transform, and it can be given as integration of 0 to infinity e raised to minus st and into function of t, or the f of t dt. So this is the mathematical definition of Laplace transform. And here we are assuming that the t is greater than or equal to 0, and we are integrating it such that t will tend from 0 to infinity. So to evaluate the Laplace transform of some of the common functions, considering that my f of t is equal to 1, so I want to find the Laplace transform of 1 where t is greater than or equal to 0. So my Laplace transform as per the definition can be given as Laplace transform of t, or Laplace transform of f of t, which is equal to Laplace transform of 1 is equal to 0 to infinity e raised to minus st into 1, which is my f of t and dt. So when I am doing integration of this, it will come up to e raised to minus st divided by minus 1 upon s, that is on doing the integration and from 0 to infinity. On solving this, it is found that when you evaluate this, the answer will be 1 upon s. And the Laplace transform of some function, like this was the first question we are solving, and if we have a function which can be given by f of t is equal to t, so if you are having a function which is given by f of t is equal to t, then it can be solved by Laplace transform of t is equal to 0 to infinity e raised to minus st into t dt. What we see that this is a integration by parts, so this can be given by u into dv by dx dt, which is equal to uv into minus integration v into du by dt. So considering that my u is equal to t and dv by dt is equal to e raised to minus st. So my v will be equal to integration of e raised to minus st dt. So which is equal to, my v is equal to 1 upon minus 1 upon s e raised to minus st, which I am solving it, then it will come like uv is equal to t into e raised to minus st minus of integration of 0 to infinity, again this is 0 to infinity, and again integration of 0 to infinity v, which is equal to minus 1 upon s into e raised to minus st into the differentiation of u, which is equal to 1, differentiation of t is 1. So again this will become 0 when you will evaluate it, and minus of minus and minus will come plus 1 upon s, and the integration of e raised to minus st is minus 1 upon s into e raised to minus st, which is from 0 to infinity. So this will, when you will evaluate this, it will come as 1 upon s into minus of 1 upon s into minus 1. So this will be solved as 1 upon s square. So it is seen that my Laplace transform of t is equal to 1 upon s square. So again, if you are remembering the integrations directly, then it's very much easy to solve. Like it's that e raised to minus of 0 or e raised to 0 is equal to 1, while e raised to infinity is equal to 0. Again, there's a specific way to solve these kind of problems, which is that if you have a problem like, which is, these kind of integrals are generally known as improper integrals, so they have to be solved by taking limits. So suppose you have a problem like going from 0 to infinity e raised to minus st f of t dt, then this can be converted as a limit of t tends to, or if you have f of b here, suppose I take a b here and function of b, then this can be solved as a function of t tends to, or b tends to infinity, while at the same time your integration will be 0 to infinity e raised to minus sb into f of b. So just taking an example of the case where my f of b is equal to 1, and the same thing which we solved can be solved as limit of b tends to infinity. Well, at the same time the integration of this was minus 1 upon s into e raised to minus sb of 0 to b. So this is limit of b tends to infinity minus 1 upon s into e raised to minus sb plus 1 upon s into e raised to 0. So as b will tend to 0, this will tend to 0, as b will tend to infinity, this will tend to 0, and as e will tend to 0, this will tend to 1, so the answer will be 1 upon s. So this is how such kind of problems can be solved in detail, while at the same time it's possible to simply remember that e raised to infinity is equal to 0, while e raised to 0 is equal to 1, and quickly evaluate this rather than going to the step of solving it by limits. So that's all about solving basic problems and mathematical definition, how to solve the basic problems and mathematical definitions related to Laplace transform.